video, we will talk about how to solve trig equations with sine. So if you have a linear equation, which means that sine is raised to the power of 1, we want to bring it to the following form. Sine of x equals to a. So that means that we want to leave sine of x on one side and move all the numbers to the opposite side. So a in this case is some number. Then we can find our angle x, so we will have two equations for our angle. Angle x could equal to arc sine of a plus 2 pi k, or angle x would equal to pi minus arc sine of a plus the period 2 pi k. Now note that arc sine of a and sine to the power of -1, or inverse of the sine, are the same things. And k in this case is any integer, so it could be 0, 1, 2, 3, 4, or -1, -2, -3, and so on. Let's look how we can apply this on the example. So we need to solve the given equation, sine of x minus 1 over 2 equals to 0. We notice that sine up here is raised to the power of 1, which means that this is a linear equation. So we want to isolate sine on one side, move numbers to the opposite side to bring it to this form, sine of x equals to a. So we will add 1 over 2 to both sides, and we will get that sine of x equals to 1 over 2. So in this case, a equals to 1 over 2. Now remember that when sine of x equals to a, there's two equations for our angle x. X equals to arc sine of a plus the period 2 pi k, and x also equals to pi minus arc sine of a plus the period 2 pi k. So now we will apply that to our equation. So if sine of x equals to 1 over 2, then x equal to arc sine of a, which is 1 over 2, plus the period 2 pi k. And we'll have another equation, x equal to pi minus arc sine of a, which is 1 over 2, plus the period 2 pi k. So this is what we have so far. Now, we can also find arc sine of 1 over 2. In general case, if you do not have those values on the unit circle, we can simply plug this into calculator and calculate what it equals to. Luckily for us, we can find arc sine of 1 over 2 using our common angles from the unit circle. So here's our unit circle, and remember that when we're searching for arc sine, we're looking at the right half of the circle. So we're looking at the angle that gives us y-coordinate 1 over 2. And that angle is 30 degrees, or pi over 6. So I will write it in radians right now, since we see that our period 2 pi k is in radians, so we want to keep it consistent. So that means that our angle is equal to pi over 6 plus 2 pi k. Now the second angle we can also find, so we will substitute arc sine of 1 over 2 with pi over 6. So we will have pi minus pi over 6 and plus our period 2 pi k. Now we can simplify this a little bit farther. So pi, we can multiply top and bottom by 6 to bring it to common denominator with pi over 6. So now we see that both of these fractions have common denominator 6, which means that now we can subtract them. So 6 pi minus pi will give us 5 pi over 6, and plus the period 2 pi k. And that will be our final answer. So x equals to pi over 6 plus 2 pi k, and x equals to 5 pi over 6 plus 2 pi k. Same thing you would have able to find on the unit circle. So on the unit circle, we see that there's two angles, 2 points that give us y-coordinate 1 over 2. That's angles pi over 6 and pi over 6. So we could have wrote wrote this answer right away as pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. Let's look at another example. We need to find all solutions on the interval from 0 to 2 pi, and our equation is sine squared of t minus cosine squared of t minus sine of t equals to 0. In this equation, we see that we have sines and cosines. So our first step would be rewrite everything in terms of only one trig function. And since we have more sines in this equation, I want to rewrite everything in terms of sine. So that means that we need to rewrite cosine squared of t in terms of sine. We recall that there is an equation that shows this relationship between sine and cosine, and that's our Pythagorean identity. Sine squared of t plus cosine squared of t equals to 1. So we can subtract sine squared of t from both sides, and we'll get that cosine squared of t equals to 1 minus sine squared of t. So in our equation, we can substitute cosine squared of t with, in parentheses, 1 minus sine squared of t. And now we will open the parentheses, and remember that minus that stands in front of the parentheses, it will affect every single term. So everything that was positive now becomes negative. Whatever was negative now will become positive. So we will have sine squared of t minus 1 plus sine squared of t minus sine of t equals to 0. Now we can combine the like terms. So we see that sine squared and sine squared will give us 2 sine squared of t. And the rest I will write in descending order. So we will have negative sine of t minus 1 equal to 0. So this is the equation that we have so far. Now notice that the largest power of sine is 2, so that means that we're dealing with quadratic equation. And if you can factor this equation without any substitution, that's awesome. If you don't, I would recommend you to do the u substitution. So we will say that let u equal to sine of t. So then sine squared would be u squared. So we will have 2u squared minus sine, so minus u, minus 1 equal to 0. And this is a quadratic equation which we can solve either by factoring or by using quadratic formula. I will be using quadratic formula right now. So according to quadratic formula, we'll have u1, u2 equal to negative b, so we'll have minus, and b, that's the number standing in front of u, so that was negative 1. So we'll have minus negative 1 plus minus square root of b squared, which is negative 1 squared, minus 4 times a, so times the number standing in front of u squared, which is 2, and times c. C, that's the free constant, which is negative 1, over 2a. So over 2 times number standing in front of u squared. And now we carefully have to simplify this. So it will equal to fraction, and minus will give us plus, so we'll have positive 1, then goes plus minus, and we will have a fraction, and negative 1 squared will give us positive 1, and negative 4 times 2 times negative 1 will give us positive 8. So 1 plus 8 will give us 9. We have square root of 9 and square root of 9, that equals to 3. And in denominator, we'll multiply 2 times 2, so that will give us 4. And now we can break it down into two answers. So the first one we'll use with the plus, so 1 plus 3, that will give us 4 over 4, so that will equal to 1. And the second one we'll use with the minus, so 1 minus 3, that will be negative 2 over 4, or negative 1 over 2. So we just found that u1 is equal to 1, and u2 is equal to negative 1 over 2. So this is what we have so far. u1 equals to 1 and u2 equals to -1 over 2. Now remember that we did a u substitution, so that was something that we invented. So we need to do the backward substitution now. We will substitute every u with sine of t. So sine of t equals to 1, and we had u2 equals to -1 over 2, so now we'll have sine of t equals to -1 over 2. And there's a little bit faster way how we can solve the rest of it using the unit circle, but I will show you how to use a general approach because that will help you in future problems. So we have sine of x equals to a. That breaks down into two equations for our angle x. Arc sine of a plus the period 2 pi k, and x equals to pi minus arc sine of a plus the period 2 pi k. So first we'll focus on the equation sine of t equals to 1. So instead of x we have t, and instead of a we have 1. So according to that formula, we'll have t equals to arc sine of a, which is 1, plus the period 2 pi k. And t equals to pi minus arc sine of a, which is arc sine of 1, plus the period 2 pi k. Now you can plug it into the calculators, or you can find on the unit circle that arc sine of a is pi over 2. So we'll substitute arc sine of 1 with pi over 2. And in the second equation, pi minus pi over 2, that simply gives us positive pi over 2. And you can notice that both of these equations are identical. The reason for that is that there's only one point on the unit circle that makes sine equal to 1, and that's the angle of 90 degrees. Now remember that we need to find all the solutions on the interval from 0 to 2 pi. So the one that we just found, pi over 2 plus 2 pi k, that's the general solution. On the interval from 0 to 2 pi, we have to plug different integers for k and see which of these angles will fit into our interval. So I will create a table with k's and our angle t. And I will plug different integers for k and see which of these angles t would fit into our interval. Now, if you think about it, there's no reason for us to plug any negative integers, because even if we plug -1, this whole angle will turn into a negative angle, which will definitely be outside of our interval. So we'll start with plugging k equals to 0. So we will have pi over 2 plus 2 pi times 0. 2 pi times 0 will give us 0, so our angle is pi over 2. And that is definitely between 0 and 2 pi, so that will be one of our answers. Now there's no need for me to plug k equals to 1, because we'll have 2 pi plus pi over 2, which will definitely exceed the interval of 2 pi. So we will move to the second equation, sine of t equals to -1 over 2. And again, remember that if sine of x equals to a, then x equals to arc sine of a plus the period 2 pi k and pi minus arc sine of a plus the period 2 pi k, which means that sine of t equal to -1 over 2 will be broken down into two equations. T equals to arc sine of -1 over 2 plus the period 2 pi k, and t equals to pi minus arc sine of -1 over 2 plus the period 2 pi k. Now from the unit circle, we can find that arc sine of -pi over 2 is -pi over 6. So we will substitute arc sine of -1 over 2 with -pi over 6. And now we'll focus on the first equation. Again, we will be plugging integers for k. So we'll create a table, k and t. And notice that pi over 6 in this equation is already negative. So there's no need for me to plug negative k's because my whole answer would be negative. and our requirements that the angle should be between 0 and 2 pi. So I will start with plugging in 0. We will have negative pi over 6 plus 2 pi times 0, which is simply equals to negative pi over 6. Now that's not within the interval from 0 to 2 pi, so that does not work. And I will try another integer for k, so k equals to 1. We'll have negative pi over 6 plus 2 pi times 1. And if we simplify it, we'll get 11 pi over 6. That's within the interval between 0 and 2 pi, so that answer works, and we'll write it into one of our answers, 11 pi over 6. And there's no need for us to continue and plug instead of k2 because that will exceed our interval from 0 to 2 pi. So we will move to our second equation, t equals 2 pi minus negative pi over 6 plus 2 pi k. So the first thing that we will do is we will combine these two. Remember that minus and minus will give us plus, so we'll have pi plus pi over 6, which will be 7 pi over 6. And again, we need to find, so this is all the angles. Now we need to find angles that are between 0 and 2 pi. So we'll create a table, k and t, and instead of k, I'll plug integers. So I will not be plugging negative integers because that will give, I see that that will give me a negative angle, which is not going to be within the interval. So I will start with k equals to 0, and that will give me 7 pi over 6 plus 2 pi times 0, which is simply 7 pi over 6. And there's no need for us to plug k equals to 1 because I see that it will exceed the interval. If you don't, go ahead, try it, and you will see it for yourself. And we'll write 7 pi over 6 as one of our answers. And we're done. So we already found the solutions within the interval from 0 to 2 pi for our given equation.